morning, students of grade 10. My name is Nir Toyana, BSc. Currently, I am available at the Hamlet Tuition Center, Brahmotol, Kathmandu, and Kumidini Kunja Secondary School, Kalimati, Kathmandu. Okay, we are going to continue our lesson through lesson of pressure. Yes, we have been recently doing the lesson on pressure. Yesterday, in our yesterday's class, what we studied? Well, we studied about Archimedes principle in our yesterday's class. Yes, and the day before that, we studied about Pascal's law. Okay, today we are going to study about the principle of flotation. Okay, you know what is the meaning of flotation or float? Okay, float means utranu. Okay, yeah, tairanu. Whenever you throw some object in water or in liquid, what happens? There are two probabilities. Either it floats on water or it sinks in water. Okay, when you throw a piece of log or a wood in water, what happens? It does not sink, it floats. Okay, it floats. But what happens when you throw a piece of rock in water? It sinks, it does not float, isn't it? Now, why is it happening? Some objects float in water, some objects sink in water. Why is it happening? What could be the reason behind this? Well, if you have studied Archimedes principle in detail, then the answer is not very difficult. We'll discuss this with reference to Archimedes principle as well. I'm going to give you three cases. Yes, case number 1. Okay, if density of object is less than density of water. Okay, this is one case. Okay, and then case number 2. In second case, if density of object is, okay, I will not say water. Okay, it would not be appropriate to say to give particular substance in general statement. I'll simply say liquid. Okay, object is same as that of liquid, second case. And the third case is if, okay, if density of object is more than density of liquid. I'm giving you these three conditions. What happened? Well, if density of object is less than density of liquid, okay, that means object is lighter than same volume of water. In such case, what happens? The object floats. Okay, remember this. If density of object is less than density of liquid, then the object floats. And if density of object is same as that of liquid, then the object, well, the object floats with completely submerged. Okay, how to say? The object floats but is completely submerged. Okay, that means to tell you. Okay, suppose this is okay, this is a vessel. Okay, and water is filled up to this level. This is a level of water. Yes, and you are given three substances. If the object you are given have less density than liquid, then if the object has less density than liquid, then the object will float with certain part of that object submerged. Okay, see here, this object has then less density than the liquid. Okay, in this case what we can write, okay, density of object is less than density of liquid. Okay, density of object is less than density of liquid. Yes, in such case the object floats. Okay, and while it floats, what you can see is certain part of the object remains submerged in water. Okay, I like gray color. Okay, anyway, any color. Okay, the certain part of object remains submerged in water, whereas you are given second object. Yes, the second object, its density is exactly equal to density of liquid. Yes, in such case what happens, what you can see, in such case the object floats. Yes, the object floats, it does not sink, but it completely submerged. It is completely submerged in water. Yes, okay. The object is completely submerged in water and still it is floating. You can say it is just floating. Yes, and if the object has more density than liquid itself, okay, let this be C. Okay, in such case what you can see, well, in such case the object sinks. Yes, this is the case in which density of object is more than density of liquid. Okay, do you understand these three cases or not? Yes, yes. Okay, let's go back to our statement here. Case 1, if density of object is less than density of liquid, the object floats, just like in object A. Okay, just like in object A. Case 2, if density of object is same as that of liquid, the object floats but is completely submerged, just like in object B. Yes, and case 3, if density of object is more than density of liquid, then what happens? The object sinks. Okay, these are the three conditions. Now, how can you explain these phenomenons? How can you explain this phenomenon? Why does this happen? Okay, now let us suppose we are going to discuss it in light of Archimedes principle. Okay, let us suppose an object whose density, just an example. Okay, density of this object is 800 kg slash meter cube. Okay, density of this object is 800 kg slash meter cube. Yes, and what is this object? Suppose this is wood. Okay, and its volume, okay, its volume is 2 meter cube. Okay, let us just suppose its volume is 2 meter cube. Okay, and it is dipped in water. Okay, let me copy the bezel from here. It would be too much to try it again, isn't it? Okay. Let it be dipped in water. Suppose that it is completely immersed. It is completely immersed in water. Yes, and you know what is density of water? What is density of water? Okay, in case of water, this is equals to 1000 kg slash meter cube. Okay. This is the density of water. Now let's say, okay, for wood, yes, for wood, what will it be its weight? Well, you know the formula of weight, mgh, isn't it? Weight is equals to mgh. Yes. Now w is equals to mass of wood. Well, we are not given mass, do we? No. Instead we can use d into v. Yes. Density equals to mass upon volume means mass will be equals to density into volume into g into h. W equals to, its density is 800, yes, its volume is 2, and acceleration due to gravity is 10, and wait, it's not mg, it's mg, m into g, sorry, I'm sorry. Okay, 10. So what does it give us? W, weight of wood, is equals to 8 times 2, 16, we have 3 zeros, 16,000 Newton. Yes. Okay, weight of wood is 16,000 Newton. That means what we know, the wood is being attracted in downward direction. Yes, the wood is being attracted in downward direction by gravity. Okay, gravity is acting gravity is acting on the wood. Okay, and what is the amount of gravity acting on wood? It is 16,000 Newton. Are you getting my point or not? Yes or no? Yes. Okay, wood, the weight of wood is 16,000 Newton. Formula of weight is m into g, mass equals to d into v. Okay, mass equals to d into v, density 800, volume 2, and g 10. So its value is 16,000 Newton. So the wood is being attracted in downward direction by the gravity, isn't it? And that amount, that force is acting in downward direction, and the amount is 16,000 Newton. Yes. Now once again, let's go through for displaced water. Okay. Okay, displaced water. What we know, that volume of water displaced is equals to volume of wood when it is completely immersed. Okay, when wood is completely immersed in water, then it will displace the same amount, its own volume of water. That means volume of, okay, that means volume of displaced water, okay, let's say it is VW. Yes, volume of displaced water will also be 2 meter cube. Okay, volume of displaced water will also be 2 meter cube. Now we need to, what we need to find is weight of displaced water. Yes, let's say this W2. Okay, this one, let it be W1. Okay, this will be W1, then we need to find W2. W2 is also equals to, once again we can use the same formula, D into V into G. Okay, so W2 is equals to, density of water is 1000. Okay, density of water is 1000 kg per meter cube. Okay, and density of, volume of displaced water is 2. Yes, because we just said that when the wood is completely immersed, then volume of wood will be equal to volume of water displaced. Okay, and the acceleration due to gravity is 10. So it gives us that. Okay, where is it? Okay, it gives us that W2 is equals to 20,000 Newton. Yes, and according to Archimedes principle, according to Archimedes principle of thrust, okay, of thrust is equals to weight of displaced water. That means 20,000 Newton. Okay, so what we can see here is the water pushes the wood in upward direction. Okay, water is pushing the wood in upward direction with certain amount of force. And what would that force be? Well, that is upthrust. Okay, upthrust okay, upthrust, that means U is equals to 20,000 Newton. Okay, see, are you seeing the problem here? Are you seeing what's happening here? No, 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 are you not seeing that? Are you not seeing what's happening? Okay, well, it's quite phenomenon. Look here, what's happening? I'll tell you what's happening. When the wood is immersed in water, two kind of forces acted on the wood. One of them is gravity, another one is upthrust. Gravity acts in downward direction, upthrust acts in upward direction. Okay, that means these forces can cancel out each other. Okay, now in downward direction there is only 1600 Newton of force, whereas in upward direction there is 20,000 Newton of force. So what is the net force here? Net force here is 4,000 Newton upward. Okay, the net force here is 4,000 Newton upward. Yes, that means the resulting force, resulting force is 4,000 Newton in upward direction. Now, will this wood continues to move in downward direction, or it will move in upward direction? By using some force, you kept it submerged in water. Yes, if you release that force, if you remove your hand, then what happens? Will this wood remain submerged in water? No, because upthrust is much greater than weight. Okay, so this wood will move upward. Okay, even until now. Okay, in this situation also, what's happening? The wood is still displacing 2 meter cube volume of water. Yes, that means upthrust remains the same. Okay, in this case also upthrust remains the same. Okay, let me move it upward. Okay, upthrust is still acting on the wood, so it has to go up further. It has to go further up. Yes, the wood has to go further up. This is what is happening. And when the wood, when a part of wood emerges out of water, then what we call this situation? This situation is called floating. That is why wood floats. Understand? Do you understand that much or not? We have to do the numerical later on. Okay. So this is the basic concept. Okay? This is a basic concept regarding what? Well, regarding flotation, law of flotation. Sorry. Okay. This is the basic concept regarding law of flotation. Okay. Now, You see, when density of object is less than liquid, then it floats. It floats. Okay. Now you can do the same regarding iron. Okay. I hope you have already copied this. Otherwise, pause the screen and copy this. We are going to take the same for iron. Let's say this is an iron. Okay. For iron, density of iron is how much? I guess it is okay. I'm going to use 8,000. Okay. So it will be 160,000 Newton. Weight of iron would be 160,000 Newton. Okay. So what will be its okay? So its weight is 16,000 Newton. Gravity is acting on it. How much, by how much amount? Okay, I'm going to select this all. Okay, I'm considering it that it is immersed in water. It is completely immersed in water. Okay. Okay. Now weight of iron is 16,000 Newton, and for displaced water, volume of water displaced would be equal to volume of iron, isn't it? When it is completely immersed. So volume of displaced water is still 2 meter cube, and weight of displaced water is still the same because its density remains 1000. So upthrust force is still 20,000 Newton. You see, we discussed yesterday that upthrust is the function of volume. Upthrust is the function of volume. Since both volume of iron and wood are same, upthrust acting on them are also same. Okay, so what you are seeing here is in downward direction 16,000 Newton force is being applied. Sorry, 160,000 Newton force is being applied. In upward direction only 20,000 Newton force is applied. Okay, look at the difference. In which direction force is more? Well, you can tell it pretty easily, quite easily. It will be 140,000 Newton force in downward. Okay, net force is 140,000 Newton in downward direction. That's why iron sinks. Okay, if downward direction gravity is more than upthrust, then it moves downward. That's why iron sinks in water. Okay, that is why the object density is more than density of liquid sinks. Okay, that is what we discussed here. If density of object is less than density of liquid, then the object floats. If density of object is same as that of liquid, the object floats but is completely submerged. And if density of object is more than density of liquid, the object sinks. Understood? Okay, now according from this calculation, what we can see that if displaced weight of displaced water would be equals to weight of object, only in that case it will be able to float, isn't it? If weight of displaced water is less than weight of object, then it is not floating, yes, it sinks. Okay, remember, if weight of displaced water is equals to weight of object itself, only then it will be able to float. Okay, that's why we can give we can state the law of flotation in this way. Okay, this part is important. The law of flotation can be stated as an object floats on liquid only if it can displace its own weight of liquid. Okay, that means in case of floating object, weight of object must be equals to weight of displaced liquid. Okay, this is the statement of law of flotation. Weight of object is equals to weight of displaced liquid, and it can be stated as an object floats on liquid only if, remember this point, only if. Okay, um, okay, um, an object floats on liquid only if it can displace its own weight of liquid. Okay, because from Archimedes principle what we know, that weight of displaced liquid would be upthrust. Yes, if upthrust is equals to weight, only then it can float. Yes, if upthrust is less than weight, then it will move downward. If upthrust is more than weight, then what happens, the object will float outside the liquid. Okay, so don't forget this statement. This is the most important part of this part of lesson. Okay, I mean the law of flotation. This part is very important from law of flotation. Okay, you will be asked to state the law of flotation, then you have to state this. Okay, and come to next part. Justify that the law of flotation is a special case of Archimedes principle. This is also one of the frequent question. Okay, justify that the law of flotation is a special case of Archimedes principle. Okay, as we know, according to the Archimedes principle, weight of upthrust is equals to weight of displaced liquid. Okay, any doubt up to here? Upthrust is equals to weight of displaced liquid. This is the statement of Archimedes. Yes, now in case of floating object, what we can say is weight of object must be equals to upthrust, isn't it? Yes, weight of object must be equals to upthrust. It is because weight of object acts in downward direction and upthrust acts in upward direction. Okay, when weight of object and upthrust becomes equal, only then the object can float in on that liquid. Yes, only then the object floats on that liquid. Okay, now from these two statements, we can conclude. What can we conclude? That, see, if upthrust is equals to weight of displaced liquid and weight of object is equals to upthrust in case of floating object, from these two equations we can say that weight of displaced liquid is equals to weight of object. Is it or not? Look here, upthrust equals to weight of displaced liquid and weight of object is equals to upthrust. Then weight of displaced liquid must be equals to weight of object. This is something like this. Okay, like if A is equals to B and A is equals to C, then what happens? B must be equals to C. Okay, this is just like that. Upthrust equals to weight of displaced liquid and upthrust equals to weight of object. Then weight of displaced liquid equals to weight of object. Okay, is there any confusion? Okay, I hope there is no more confusion. And you can see weight of displaced liquid equals to weight of object. Yes, in what case the weight of object? In case of floating object. Yes, because in second statement we have said this, in case of floating object, and this is the statement of law of flotation. See, this is the statement of law of flotation, and we derived it from Archimedes principle in case of floating object. That is why this is law of flotation is special case of Archimedes principle. Okay, since it was derived from Archimedes principle by using a condition, that is floating object, law of flotation is a special case of Archimedes principle. Okay, okay, this is very important question. Yes, okay, there is no confusion in this part. Okay, shall we go to next part? Okay, next part, say okay, let me continue from this. Okay, another question is, an iron nail sinks in water, but a ship made up of iron floats on water. Why? Well, and we know that upthrust, what is the formula of upthrust? D G into V, isn't it? That means upthrust is proportional. Okay, once again I need the proportionality sign. Okay, where to get? And I hope in this software I am using, there is a function called glyph. Okay, from here I can get symbols. Okay, is there proportionality sign here? I guess this software, this app is better than the one I have been using last time. Okay, symbol section, it is not there. In math symbol, can you say it? Okay, this is infinite sign. Okay, there is no symbol. Okay, let me see it. Let me find it in orders. Let me see it in Greek letters. Is there? Okay, where is it? Come fast. Okay, I cannot find it here as well. Okay, I'll pause the screen until I find it. Okay, I found the sign. U is proportional to V. Let me close it. U is proportional to V. Upthrust is proportional to volume. Yes. Now, an iron nail has very small volume, that is compact. Okay, and is not able to displace enough water, as it has very high, okay, it has higher density than water, isn't it? Iron nail has very small volume. Okay, so very small amount of, okay, so upthrust acting on it is very small, and it is not able to displace enough water, as it has higher density than water. Now, in case of ship, what happens? An iron ship is constructed by keeping it hollow from its side. Okay, that increases its volume and decreases its density. Okay, so upthrust acting on it is very large, and it is able to displace water equal to its own weight, as it has lower density than water. Okay, so an iron nail sinks in water, but a ship made up of iron floats on water. Okay, look at the question once again. Yes, this is also an important question to you. Yes, we know that upthrust is equals to dg and v, and u is proportional to v, keeping d and g constant. An iron nail has very small volume, so upthrust acting on it is very small, and it is not able to displace enough water as it has higher density than water. Yes, we have discussed in our previous section also that if upthrust is less than weight, it floats, but it sinks. Yes, is it or not? You can write it in bracket, upthrust. Okay, since upthrust is less than weight, it floats. Okay, you do not need to write it in your reason. Okay, this is written as okay, color swatch. Okay, you do not need to write it down. Okay, that's why I highlighted it in pink. Okay, but here what is happening, since upthrust is larger than weight, it floats. Okay, it made a mistake, it sinks. Okay, so in this case, this part also I'd like to highlight. Okay, this much. Yes, these two questions are special questions. Okay, just take out these two questions, try to understand this very perfectly. Yes, now in case of ship, look here, this is a ship. Okay, but you can see that a ship is not entirely above water. Certain part of it is sink in water, and that part is called hull. Hull, hull. Okay, hull of ship. Yes, the part of ship which is sink in water is called hull. Okay, now what I want to discuss here is, there is one more question. Okay, question: what happens when some load is added on the ship? What happens? Well, suppose by sinking this much part of ship, it is able to displace certain volume of water. Yes, and that amount of displaced water has same weight as the entire weight of the ship. Are you getting me or not? By submerging this much volume of ship. Okay, do you want an example with number detail? If so, yes, I can do that. Okay, let's say this is the level of water. Okay, and a ship. I need to draw a ship. Sorry. Okay, this is a ship and it is carrying large amount of loads. Yes, it is carrying a lot of loads. Okay, let's say that overall density of this ship, along with the load is let's say 700 kg per meter cube. Okay, okay. Of course, that density of iron would be much more, isn't it? But we already said that the ship is made hollow from inside, so that its volume is less than, so that its density is less than density of water. And let's say its volume is 1000 meter cube. Okay, its volume is 1000 meter cube, and let's say that density of water dW is equal, so we know it is 1000 kg slash meter cube, isn't it? We know that density of water is 1000 kg slash meter cube. And by applying a formula called D1 P1 is equals to D2 P2. Okay, I'm going to find out what volume of ship would be submerged. Yes, D1 is 700. Okay, and we don't know V1. Okay, yes, V1 is 1000, isn't it? Equals to D2 is 1000, and we don't know V2, or it gives us V2 is equals to 700 meter cube. Okay, so what does it tell us? That volume of this submerged part is 700 meter cube. Okay, 700 meter cube volume of the ship. This much part is submerged in water, and that is indicated as V2. Okay, V2 means what? Displaced volume of displaced water. Okay, so this needs to displace how much water to float? It needs to submerge 700 meter cube. This much part of ship has to submerge. But what happens if you add load? If you add load, then its overall density increases, isn't it? Let's suppose its overall density increases to 750 kg per meter cube. Okay, in that case, here it will receive 750, and the volume will come 750 meter cube. That means, what does it mean? It means that for this ship, after adding load, okay, I forgot to add some load. Yes, okay. After adding this load, this ship has to displace 750 meter cube of water to float, isn't it? So how will it do it? Well, to increase the volume of water, what will it do? It will sink more, isn't it? It will sink more. Okay, by sinking more, it will be able to displace more amount of water, and when the displaced water is exactly 750 meter cube, it stops sinking. Okay, again it comes to balance. Understood? Now if you keep on adding more and more load, so that its density becomes equals to or more than density of water, in that case what happens? The ship would sink. Understood? Okay, so what should be the answer to this question? See here, what should be the answer to this question? When some load is added on the ship, its overall density slightly increases. Yes, so it has to displace more amount of water to stay afloat. And how will it do that? It will do that by sinking its hull slightly more. Okay, very simple. Yes, it has to displace more amount of water to stay afloat. It will do that by sinking its hull slightly more. In this way, weight of displaced water is increased. Okay, so this much is today's lesson. Okay, you need to do some questions, and before that do some revision as well. Principle of flotation, case number 1, case number 2, and case number 3. Study these 3 cases properly, because mostly objective questions are asked from this much part. Yes, if density of object is less than density of liquid, the object floats, and if density of object is more than density of liquid, the object sinks. Okay, and then after, this is just an example, you do not need to copy this. Okay, this is just an example. Okay, and this is an example to illustrate these 3 concepts. You just need to take out these 3 cases concept. You do not need to copy this one. Yes, and then after, this is the important part. This is an important part. Law of flotation. State the law of flotation. Let me make it bold. Okay, and if you want it to be highlighted, let me do that as well. Okay, it's not doing the trick. Anyway, copy this one. This is very important part. Okay, and then after, few questions which are very frequently asked in your SEE exams. Justify that the law of flotation is a special case of Archimedes principle. An iron nail sinks in water, but a ship made up of iron floats on water. Why? And then after, what happens when some load is added on the ship? Okay, okay, one more question is there. What happens when a ship enters into river from ocean? You know what happens? As we know, upthrust is I need the proportional sign. Where is my glyph? Okay, it is already gone. Okay, I need to take it again. Glyph. Glyphs. Okay, U is proportional to D. Okay, and ocean water, sorry, river water has, we all know this, less density, isn't it? Okay, river water has less density than ocean water, so it has to so it exert less upthrust than ocean water. Okay, what's happening here? I don't know what's the problem. Is there any other object? Okay, I don't think so. Okay, so it exerts less upthrust than ocean water. Okay, hence for a ship to remain afloat, the ship has to displace more water. Once again, it does so by sinking its hull slightly more. Okay, this much is today's class. Okay, I hope you enjoyed today's class and you understood the concept behind this. We still need to do some numericals related to principle of flotation. Okay, in our tomorrow's class we will focus on numericals. Thank you, class.